We solved up to 27 questions, huh? In previous class. Say something. Open your target booklet. We solve few more questions and then we will continue. Right? We are solving exercise question. In that, already we solved first 27 questions of exercise. Now we are at question number 28. See that one? Major product obtained from E2 elimination of 3-bromo 2-fluoropentane. E2 elimination, sir. E2 elimination means occurs via concerted mechanism, anti-periplenarity condition. E1 elimination means carbocation intermediate. E1 CB means carbanion intermediate, right? So here reaction should proceed via concerted mechanism. So 3-bromo 2-fluoropentane. 1, 2, 3, 4, 5. 3-bromo 2-fluoropentane. Now I am using alcoholic KOH. Now reaction should proceed via E2 elimination means base has to pull H plus, bond has to shift, and leaving group has to leave. All should happen in single step. Now, can I say hydrogen present here is acidic because of minus IU? Same way, bromine also, over this carbon also it is acidic. But among these two hydrogens, which is more acidic? Yet fluorine, correct? Because fluorine is more electronegative element. So, I am taking hydrogen present here. Better I will write that fluorine like this. I will write that fluorine like this and a hydrogen like this. Now base pulls this H plus out. This bond will shift and this bond will leave. Anti-periplanar condition satisfied or not? Right? E2 elimination. So product will be here there is fluorine, double bond, ethyl. Correct? Correct, sir? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So product must be option 3. Suitable or not? 1, 2, 3, 4, 5. Over second carbon fluorine, over second carbon double bond should be there. Right? Any questions in it? Online. No one is responding. Acceptable.
So no doubt, sir.
Now come to next one. Major product in this reaction. Base is given. Good base. Sodium ethoxide in presence of ethyl alcohol means very strong base. Sodium ethoxide in presence of ethyl alcohol. Very good base is given. Bromine is also a good leaving group. Right? As this is good leaving group, it can follow carbocation intermediate. If I am getting carbocation intermediate, reaction is proceeding via E1 elimination. Good base is there. Good leaving group is also there. So you will get carbocation. So what is that carbocation? CH3, CH, CH3, bond, C, CH3, CH3 plus. Tertiary carbocation, right? Correct or not? Then what C2H5O minus gives? Base will pull H plus out to form a double bond, right? So C2H5O minus will pull this H plus out, making a double bond here. You will get stage of product as major product. Response, sir. If it is a bulky base, then if the base is very bulky, then I will get half and product as major, means I will get double bond here. Now I got double bond here, more substitute alkene as a major, right? This will be minor. If there is a bulky base, this becomes major. Half and product becomes major. Correct, sir. So what should be the answer? What should be the answer? Option 1. Respond. So option 1 is correct or not? Now see the next one. Question number 30. Bromopropane in presence of some nucleophile or maybe base. There is competition between substitution and elimination. Both are happening. Now see this. This is bulky base, right? Or I can say this is very strong base. Because of donating groups, negative charge over oxygen is high. So it is very strong base. So strong base will try to eliminate. Correct? So if this eliminates, reaction will proceed via K. What is that? E. This is Ks, this is Ke. So Ke is preferred. So in case of B, Ke is preferable. Check the options. In case of B, Ke is preferable, means Ke of B is greater than Ke of A. So answer should be among C and D. Correct or not? So as this is very strong base, it always try to pull the H plus out. If it pulls the H plus out, bond will shift and Br will leave. Reaction will proceed via E2 mechanism. Now, here, along with elimination, substitution is also favorable. This nucleophile will go and attack here, Br will be replaced. So both are possible. Now, which will dominate? In this case, definitely elimination dominates. That means in this case, substitution dominates. Means rate of Ks will be greater than Kb. Ks, oh, they have not given. Huh? Okay, they gave mu. Ks is more than Kb means mu of A is greater than mu of B. Mu of A is greater than mu of B. So answer must be option 4. Response, sir. Understandable or not? As this base is bulky, elimination is preferred. In this case, substitution is preferred. Clear? Next one, sir. What is this tertiary butoxide, bulky base? Tertiary butoxide, bulky base. Bulky base prefers to Hoffman product. But what type of group is this? Very good leaving group. Iodine is there, na? Iodine is very good leaving group. As this is very good leaving group, it leads to formation of carbocation. So it leads to formation of carbocation. That too secondary carbocation. Secondary carbocation undergoes rearrangement. During that rearrangement, H will migrate. So you will get positive charge here. Bond, bond. Correct? Correct or not? Now what base will do? Base will pull the H plus out to form a double bond. So to form a double bond, first option and third option both are possible. So I may get double bond here plus another possibility to get double bond here. These are the two possibilities, correct? This is a Hoffman product and this is Sagejeff product. So which will be major generally? Base is bulky, man. Hoffman product is major. So answer should be option 1. Answer they gave third option. Why? You gave bulky base, right? Oh, hey, it is not base, man. It is tertiary butyl alcohol, I think. Check. It is tertiary butyl alcohol, not tertiary butoxide. It is solvent. Respond. It is not tertiary butoxide in presence of tertiary butyl alcohol. It is not bulky base. It is only solvent. Right? If it is only solvent, which should be major? CHF is major. If it is a base, if they have given tertiary butoxide, bulky base, then Hoffman becomes major. Right? So answer should be option 3. Means this is the solvent. Solvent is interfered means its reaction should proceed via even mechanism. Response, sir. Right. Next one. Methoxide presence of methyl alcohol means good base, right? Base will pull the H plus out. So can I pull H plus out from here? Can I pull this hydrogen, making that bond to shift here and bromine to leave? So product will be a double bond here. Possible or not? Response, sir. Proceeds via E2 elimination. Possible, right? Any questions? Or if base is a strong base, reaction proceed via E2. If a leaving group is very good leaving group, but base is not strong base, then even, right? If a more acidic hydrogen is present, then carbanion, even CB mechanism. Correct or not? So here answer should be option 2. Next one, sir. 20% phosphoric acid followed by heating means elimination. Alcohols in presence of acid on heating, dehydration. Reaction will proceed via carbocation mechanism. So you will get carbocation here and you will get CHF product as major product. So answer should be this. Here you could take an bulky base. The sodium, and this is potassium butoxide. Correct or not? Tertiary butoxide in K plus is given. Means bulky base. Bulky base means I should get Hoffman product as major. Means this one. So answer should be option 3. Respond. This is the reason I told you to bring your target booklets, simultaneously solve. Any questions in this? Next one, sir. Which of the following compound undergoes replacement of chlorine by OH by merely warming compound with aqueous NaOH? Replacing of chlorine and OH over benzene ring. Then what we call it as aromatic nucleophilic substitution reactions, right? So that occurs readily in presence of withdrawing group. So answer must be option 4. Response, sir. Any questions in this? So next one. Oh, here iodine is there. We are doing coupling reaction, right? In presence of copper, if I heat, what it is called? Ullmann. Right? You will get biphenyl product. So answer must be option 2. Check, sir. Check the answer keys, sir, simultaneously. Correct or not? Respond. Next one. In its nucleophilic substitution reactions, aryl halides means halogen present over benzene ring. This is aryl halides. They will resemble with vinyl halides because here also halogens are present over unsaturated system. Here also halogen present over unsaturated system. So answer should be option 1. Correct or not? Allyl and benzyl, these two are like one thing. Vinyl and phenyl will be of one type. Here substitution over unsaturated carbon. Here also substitution should occur over unsaturated carbon. Here both are stable. Allylic and benzylic substitutions. Correct? Next. So we are done with that exercise. So we are going to see polyhalogen compounds, right? So what we are doing is polyhalogen compounds discussion in our target booklet is less compared to Invictus. So I am discussing from Invictus target for polyhalogen derivative, right? So in that, first we will complete that polyhalogen derivatives, then we will start numerical solving again. So to what extent we have discussed in previous class? We are done up to carboylamine test, right? We are done up to carboylamine test. Alkyl and aryl halides. It is taking too much time. It opened, I can see. This is man. Now say this. So first regarding classifications, done or not? Alkyl halides, allylic halides, benzylic halides, vinyl halides, aryl halides, nomenclature. After that, methods of preparation of alkyl halides. This is nothing but halogenation of alkanes, radical substitution mechanism, preparation of aryl halides and alkyl halides from alcohols. What is this method? Groove's method, Lucas test, identification of primary, secondary, tertiary alcohols, right? Then with SOCl2 with PCl5, if it is SOCl2, what is this name reaction? Dargens. Reaction proceed via SNI mechanism. Next, in presence of ZnCl2 and HCl, Lucas test. Then addition reactions, electrophilic addition reaction, H plus X minus, correct? A reaction proceed via Marconi product. If it is done in presence of peroxide, anti-Marconi, that peroxide effect or Karash effect is observed only in case of HBr. It fails in HF, HCl, and HI. Finkelstein, done or not? Sodium iodide in presence of acetone. Then SWAT. Then boradine Hinz-Diker. Here we discussed one more reaction also. Birbon-Simonini, formation of esters. Then polyhalides, physical properties done. Chemical properties also. This is about substitution reactions, SN2. Then all these reaction substitutions we have seen or not? Then neighboring group participation. Then SN1 unimolecular carbocation intermediate. Then stereochemistry, retention in configuration, inversion slightly dominates retention here. In case of SN2, Walden inversion. Then SNI, we have seen Dargens. Examples. Then E2 elimination. Said Jeff Hoffman. After that, Hoffman also we have done. Dehydration of alcohols via E1, E2. Generally, they prefer to undergo by E1. Then E1 CB, EI mechanism. Here we discussed cope elimination. Then pyrolysis of esters also we have seen, right? Then Hoffman exhaustive methylation, formation of alkenes having beta hydrogen. After that, again examples. Then aryl halides, preparation of chlorobenzene, chlorine presence of iron or zinc or aluminum, right? What we call them as electrophilic aromatic substitution reactions. This is also done. Then during halogen iodination, we have to use HNO3. Otherwise, reaction proceed in backward direction. Iodination should be done in presence of oxidizing agents. Correct? Then in terms of CuCl2, from diazonium compounds, Steinmeier reaction, Balch-Schimann reaction, Getterman reaction, done or not? Then silver salt, borodine Hinsliker only again. Then decarboxylation, sodium hydroxide, calcium oxide, soda lime. I have to remove CO2, right? So if this is gone and followed by adding H, you get this converted into benzene. Next one, physical properties again. Melting boiling point difference between ortho, meta, para, dichloro derivatives. This is also done. Polarity, all these things are one. This also we have done. OH minus will go and replace Cl. This reaction proceed via two mechanisms: addition, elimination, elimination, addition. Correct or not? We call them as nucleophilic aromatic substitution reactions. So this is also done. Here, sign substitution means over this carbon, if NH2 comes, then this is direct product. On adjacent carbon you will get, then it is called sign substitution product. Benzene mechanism, man. Reaction proceed via benzene mechanism. Next one, electrophilic aromatic, sulfonation, all these things are by using with metals, using Grignard reagent with the sodium. What is this one? Hey, Fittig, Urj, Fittig, Urj, Urj, Ullmann. Already we have seen these things now. If it is copper, Ullmann. Just now we have seen this one. Then with the lithium compounds, organometallic compounds. Next, this is formation of DDT, reduction. Now we are discussing about these things, polyhalogen compounds, right? In this already methane, this product is over. Chloroform is already over. Then haloform reaction already over. Respond. Phosphagen. Why we should not store haloform in presence of sunlight, or why we have to store from away from sunlight, and should be stored in amber color bottles. So with atmospheric oxygen, it will be oxidized to form phosphagen, poisonous. That's why we have to add some amount of ethyl alcohol. With ethyl alcohol, these chlorines will be replaced, right? So then it converts into non-poisonous product. Production also over. Chloritone also done. This is also over. Chloropicrin is over. And this is carbylamine test. This is also over, right? So up to here we are done. Now we are going to discuss about this one. Mechanism also we have completed. See, up to here we have done carbylamine test. If it is a primary amines, in presence of chloroform and base, they will convert into isocyanides. We call it as carbylamine test, respect to mechanism, right? Next, on reaction proceed via what intermediate? Carbene intermediate, right? Next one, reaction with silver powder. Seventh reaction. Reaction with silver powder. So halo form means I am taking CHCl3. I am writing that in this way. CHCl3 allowed to react with silver. And this side again I am writing CHCl3. I am taking 6 moles. Right? Chloroform and silver. So totally 6 moles of AgCl will be lost. If 6 moles of AgCl is lost, there will be triple bond formation between carbon and carbon. So it leads to formation of HC triple bond CH. So leads to formation of acetylene. If this is the acetylene is passed over red hot iron tube. Yes. Red hot iron tube. Leads to formation of benzene. Right? This is one more reaction. Next one. Chlorination reaction. Chlorination. Chloroform CHCl3 allowed to react with chlorine in presence of sunlight. Chlorine in presence of sunlight. What happened? Radical mechanism. One more H is replaced by chlorine. So product will be CCl4 plus HCl. Right? Carbon tetrachloride. Next reaction. Reimer-Teimer reaction. Very, very, very important reaction, sir. Reimer-Teimer reaction. Reimer-Teimer reaction. Stop talking. Now say this. While we are discussing about alpha elimination, in case of alpha elimination, you will get carbene as intermediate. Carbene is intermediate in 2 named reactions. What are they? One is carbylamine test. Second one is Reimer-Teimer reaction. Just I am showing it again. During elimination reactions, during elimination reactions, we discussed about alpha elimination. Alpha elimination means both hydrogen and halogen should be lost from same carbon. Right? So what is this? This is chloroform only, na CHCl3. When chloroform is allowed to react with alcoholic KOH, first H plus is removed, you will get anion. Then Cl minus is lost, so you got carbene. Carbene is intermediate in 2 named reactions. One is carbylamine test. Second one is Reimer-Teimer reaction. Right? Reimer-Teimer reaction. 2 important reactions. In both cases, carbene is the intermediate. One already we have seen, carbylamine test. What is that carbylamine test? Primary amines. I am repeating one more time. primary amines. Is it primary amine or not? Nitrogen connected to only one carbon. So it is called primary amine. If primary amines are allowed to react with chloroform in presence of base, what these two will do first? Chloroform and base leads to formation of carbene. Alpha elimination leads to formation of carbene, that is CCl2. This is carbene. Now nitrogen have lone pair. Now this nitrogen will donate lone pair of electrons into this. Then leads to formation of NH2 plus, and this will convert into C, Cl, Cl minus. Correct? Huh? Then next step, what happen? H plus will move from here to here. Correct or not? So if H plus is gone, what you will get? NH. This is NH, lone pair. Here you will get H, chlorine, chlorine. Correct? Huh? In next step, this nitrogen will donate lone pair, making this chlorine to leave. Then what you will get again? Again you will get NH positive charge, carbon, hydrogen. Here you will get a double bond. Correct, sir? One chlorine is lost. You will get this one. Right? Now again base will pull this H plus out. Then it leads to formation of N, lone pair, double bond, C, H, chlorine. Now again base will pull this H plus out. Then what you will get? Nitrogen, double bond, carbon with negative charge, and chlorine. Next step, this nitrogen will donate lone pair, making this chlorine to leave. So leads to formation of N, triple bond C, positive charge over nitrogen, negative charge over carbon. So what it leads to formation of? Isocyanates. So primary amines in presence of chloroform and base leads to formation of isocyanates. What is the intermediate? Carbene is the intermediate. What we call this reaction as? Carbylamine test. Any questions? So we are already done with this. Now we are going to see the second one. That is nothing but Reimer-Tiemann reaction. Here, phenols react with chloroform and base it will form salicylaldehyde. This becomes major product. We call this as Reimer-Tiemann reaction. Observe the reaction. This is phenol allowed to react with CHCl3 in presence of base. Product will be, here I am writing OH, here I am writing aldehyde. Salicylaldehyde is the major product. Right? Reimer-Tiemann reaction. So instead of this, if the same phenol, instead of chloroform, if I take carbon tetrachloride, CCl4 in presence of base, then you will get salicylic acid as a product. Right? Now observe the mechanism of it, how the reaction occurs. First step, First step, what happened? Chloroform react with base to form. First step, what happened? This is a chloroform. CHCl3 first will react with base. This OH minus pulls H plus to form H2O. If H plus is lost, it leads to formation of CCl3 minus. Correct? Now this CCl3 minus will lose a Cl minus, lead to formation of CCl2. This is nothing but carbon. This is step 1. Right? Now second step. This carbon should go and attack over benzene. Right? Now already we discussed now this carbon can act as electrophile because it is electron deficient or not, empty orbital, right? So can act as electrophile. Now second step, phenol react with base to form phenoxide ion. Now this phenoxide ion can show resonance. This can shift here, making this pi bond to shift here. Possible or not? So during resonance, I may get negative charge at ortho position, or I may get negative charge yet para position also. Correct, sir? And this may shift back and making this pi bond to shift. Possible or not? So I may get negative charge either at ortho position or para position. Right? Now, as we have more electron density either at ortho carbon or para carbon, this can donate that lone pair of electrons to carbon. So I am taking that step. So double bond minus, I am taking carbene. This will donate lone pair of electrons here. Now lead to formation of what you will get now. Double bond O, bond C, chlorine. Now I will write this negative charge. Instead of lone pair, I am writing negative charge because it is gaining electrons. Right? And the top, do this carbon is having hydrogen also. At this carbon, we have hydrogen also. No? That hydrogen also I have written. Now, this hydrogen migrates from this place to this place. Possible or not? If that hydrogen migrates from here to here, you will get negative charge that will shift and this converts into O minus again. So I got O minus and a double bond here, and this converted into C, Cl, Cl, H. Now, if it is allowed to react with base, we are adding base now. That base can substitute this chlorine with OH group. How many times? So 2 times it is possible. Then what it will convert into? Aldehyde. Correct or not? Now observe this one also. And I think we discussed this in amines chapter. Just I will show that and I will come back. Observe, sir. First step, carbene. Second step, are you able to understand? Up to here I have shown. Then OH minus will go on attack, making the Cl minus to leave. Right? Then from here H came here. It forms O minus. This bond will shift it, making that Cl minus to leave. Finally convert into aldehyde. Same way, if it attack at para position also, same. That's why it can attack either at ortho position or may attack at para position, because during resonance we are getting that negative charge at ortho as well as para. Both are equally possible. Correct or not? So next step, base will go and attack, making this chlorine to leave. So Cl minus is lost. So product will be O minus, here C, OH, hydrogen, chlorine. Now this O minus pulls this H plus out. This bond will be shifted. This chlorine is lost. So product will be OH, C double bond OH. You got salcylaldehyde. Correct, sir? Right? So during this reaction, totally 3 moles of base is used. That's why if you see that reaction, ClCl3 3 KOH. So 3 moles of KOH is required. So better I will write the same thing here. Here also we will write the same. We will write here it as CHCl3 plus 3 moles of KOH. So you will get ortho product. Along with ortho product, minor product will be para also. Response, sir. Not only ortho, you will get para product also as byproduct. And you will get 3 KCl plus H2O. How many times? How many times you are getting H2O? 2 times. 3 KCl, 2 H2O. 1 H2O you are getting here. Second H2O you are getting here. 2 times H2O we got, right? So plus 2 H2O plus you may get para product also, para salcylaldehyde also as a byproduct. But which is major? Ortho becomes major. This is Reimer-Timer reaction. Any questions are in this? Respond. Do you have any questions in this? Online?
No,
Online,
sir.
someone respond.
Yes, sir.
Right? Next.
Yes, sir.
So let me adjust this a little. I think no need of adjustment also. It is perfect. No issue. Next, sir, I am taking one more example. Here, one previous JEE advanced question is there, where most of them will give wrong answer. That is, see this example. I am taking one more aromatic ring, sir. Is it aromatic compound or not? Pyrrole. Now, pyrrole is allowed to react with CHCl3, chloroform, in presence of base. Now, what should be the product? Pyrrole reacts with chloroform and base. What should be the major product? Here also same. Carbene. Carbene is the intermediate. Once you get carbene intermediate, this nitrogen will not donate lone pair because this lone pair involved in delocalization. If a lone pair is available over nitrogen, carboylamine test. Here lone pair involved in delocalization. So Reimer-Timer reaction. So carbene will approach. Now nitrogen will donate lone pair. This will shift here. So product will be correct or not? You are getting negative charge here. So carbene will go to that position. Finally, you will get this converts into aldehyde. Correct? Finally, after a few steps, it will convert into aldehyde. Response, sir. This is what we generally expect. Now observe another possibility, sir. The other possibility, observe carefully. This carbon is having negative charge now, and this nitrogen is having positive charge, right? Now here there is hydrogen. Instead of migrating this hydrogen to here, now we are trying to make this to attack here back and to restore its lone pair back. This is also possible. Then what it will form? You will get a 3-membered ring there. Possible or not? In this way, a 3-membered ring. Respond. Right? Now, base will pull this H plus out. If base will pull this H plus out, you will get negative charge here, correct? Now this bond will shift here, making this a Cl to leave. Then what happens to size of this ring? I see this. Base pull this H plus out. Okay, don't pull that also. I will do one thing. I am shifting this bond here and made this Cl minus out. Then what happens to this carbon? Gets positive charge. Now size of this ring becomes 6-membered ring or not? This got shifted. So here it is hydrogen. You got positive charge here. Correct? Here chlorine. When this got shifted, here it becomes a double bond. Right? This is the product obtained. Correct or not? This bond shifted and this Cl is gone. So over this carbon, only one chlorine is present. And here there is a double bond formation. Correct? Now I will remove H plus from here. Or I will make this nitrogen to donate lone pair here, making this bond to shift here. So what you will get now? Nitrogen, bond, hydrogen, positive charge, double bond, bond, chlorine. Then in next step, I will pull H plus from here. Then what happens? It converts into 6-membered ring. This is another possible, right? So this becomes major than this. Observe this reaction. Corresponding mechanism. Pyridine, pyrrole with chloroform in presence of base. These are two products we generally expect, but which becomes major? That 6-membered ring becomes major product. Corresponding mechanism, right? Via 3-membered ring expansion happened, and this becomes major. Remaining as usual. You are getting aldehyde is as usual, right? There is no deviation in it. So this is one important reaction. So I don't want this all nonsense. So direct I am writing. So I may get aldehyde group here plus you may get aldehyde group here plus you will get a 6-membered ring. Pyridine having chlorine here. So among them, which becomes major? This 6-membered ring becomes major. Primer-timer reaction. Any questions are in this? Right? Here also, what is intermediate? Carbene is the intermediate. Done? Any questions? No. Not this one. This one. Uses of chloroform. Next heading, uses of chloroform. I am taking the things as it is from Invictus, right? In that first one, chloroform is used as solvent, chloroform used as solvent in oils and varnishes. As a laboratory reagent, as a preservative, and in production of freons. Already we have seen nomenclature of freons, correct, sir? Freon refrigerant R22. Name of the freon, that last numbers depends upon, we discussed one formula, nomenclature of freons. Not seen, huh? But I remember freon nomenclature we discussed. Here. Nomenclature of freons. They will be written as freon CBA. C represents number of carbons minus 1. B represents number of hydrogens plus 1. A represents number of fluorines. Right? So if it is CCl2F2, then we will write as freon. Number of carbons is 1. 1 minus 1, 0. So 0. Then number of hydrogens plus 1. Number of hydrogens 0. So plus 1 means 1. Number of fluorines 2. So I will write 2. So it is a freon 0, 1, 2. So we write as freon 1, 2. Clear or not? We will do one thing. Done. Freon's nomenclature we have done. Right? Next one, sir. Triiodomethane. So CHI3, preparation and properties. Triiodomethane. We also call it as iodoform. Iodoform preparation and properties. First, regarding preparation. How to prepare chloroform? Very, very important neighbor reaction. In this chapter, important neighbor reactions are Borodin, Huntsdaker, Wittborn, Simonini, then Finkelstein, Swart, then Lucas or Bruce, then Dow's process, formation of phenols. Chlorobenzene in presence of base forms phenols. Right. Next one. Targens in presence of SOCl2. Targens. Fittig, Wurji-Fittig, Ullmann, right? Gilman. Then Grignard reagent. All these are nonsense only. Same. Right. Next. Trimer, carbylamine. Right. Now, haloform reaction. In which cases haloform reactions will be positive? In which cases haloform reaction will be positive? Again, I am repeating. Again, I am repeating, sir. Haloform reaction, I am repeating. Listen again. Condition. If we have an aldehyde or keto group, then next carbon I call it as alpha carbon. If this alpha carbon must be methyl group, then haloform reaction is positive. Aldehyde or keto groups, next carbon is called alpha carbon. That alpha carbon must be methyl group. Then alpha methyl group shows a positive test for iodoform or haloform reactions. Right? Again, I am repeating. For example, I am taking CH3CHO. Do that condition satisfied or not? Alpha methyl group is there, so test is positive. Correct? Now it is allowed to react with either chlorine or iodine in presence of base. Now what base will do? Base will go and pull acidic hydrogen. So it can pull this hydrogen now. Reason, it can show tautomerism to form CH2 double bond COH. Tautomerism are possible or not? This bond will shift here, this will shift here, H migrates from here to here. Means this hydrogen is acidic hydrogen or not? As this is acidic hydrogen, OH minus can pull this H plus out. So H2O is lost. If H2O is lost in presence of base, if H2O is lost, what you will get? O minus. And if H plus is gone, O minus. That will shift back. This shifts back. What you will get? You will get CH2 minus CHO. Correct? Huh? Now this will react with iodine. I bond I. Right? Now, if it is I2 present, I bond I. This will donate lone pair of electrons here, making this I2 leave. So I minus is lost. So product will be. If I minus is lost, CH2 I. Correct? Now, what about acidic nature of this hydrogen? Enhanced now. Compared to this, it is even more acidic. So base will take another H plus easily. So base will take another H plus here. H2O is lost. So product will be CH minus I aldehyde. Correct? Now this will react with I2 again. Now product will be CHI2 aldehyde. Response, sir. Now it can react with base again. Again, it reacts with base and H2O is lost. So product will be C minus I2 CHO. Again, it will react with I2. I minus is lost. So product will be CI3 C double bond OH. Correct? Now again base. Now base cannot pull acidic hydrogen. Now base acts, this OH minus acts as a nucleophile. Correct? Because CI3 is good withdrawing group. Because of this withdrawing nature, what happens to electron density over this carbon? Decreases. So OH minus will go and attack. So product will be CI3 bond CO minus HOH. Correct? Then this will come back, making this to leave. So product will be CI3 minus plus HCOOH. Correct, sir? As this is acid, acid gives H plus readily. So that H plus goes here. So product will be CHI3 plus HCOO minus. So what you got? iodoform. If chloryl is taken, chloroform. If it is bromine, bromoform. If it is iodine, iodoform. What is the name of, what is the compound we are seeing now? We are seeing iodoform reactions, right? So iodoform preparation properties. So instead of all these products, what we can write directly? First reaction, acetaldehyde. Can I write it or not? Acetaldehyde reacts with NaOH plus 3I2. Why I am writing 3I2, sir? I am using iodine 3 times or not? Here once, here second time, here third time. Am I using I2 3 times or not? And how many times I am using OH minus? OH minus here once, here second time, here third time, here fourth time. So I am using NaOH 4 times. Correct? So product will be CHI3 plus HCOO minus Na plus. Correct, sir? This will convert into salt or not? Plus 3 moles of NaI plus 3 moles of H2O. Any questions are in it? Iodoform reaction. Respond. So all this stuff is not necessary for over. Preparation of iodoform, which is yellow color precipitate. Iodoform is yellow colored solid. Here I will write like this. Iodoform, yellow color solid. Right? Now, which are the other compounds shows positive test? Among alcohols, among primary alcohols, only one primary alcohol shows positive test. That is ethyl alcohol, CH3CH2OH. Among primary alcohols, only ethyl alcohol shows positive test. Reason: iodine in presence of base acts as a oxidizing agent. Oxidizing agent, mild oxidizing agent, oxidizes alcohols to aldehydes. Are you able to understand? This is primary alcohol. No? Primary alcohol will be oxidized in presence of I2 and base. It will be oxidized to aldehyde. If it is converted into aldehyde, do these conditions satisfied or not? Then iodoform test is as it is. Means primary alcohols also shows positive test. Now among secondary alcohols, only two alls will give positive test. Reason: if we have OH group only at second carbon, then only this on oxidation converts into C double bond O. If it converts into C double bond O, then only alpha CH3 condition satisfied. Correct or not? So among primary alcohols, only ethyl alcohol. Among secondary alcohols, all two alls. Tertiary alcohols fail. Among aldehydes, only acetaldehyde. Among aldehydes, only acetaldehyde. Among ketones, all two ones respond. Right? In addition to that, chloral, so it shows positive test or not? So it shows positive test or not? Because this somewhere in between forms this only, na? Or if I take acetaldehyde, in between it is forming this only, na? So chloral also shows positive test for haloform reaction, right? In addition to that, resorcinol, fluoroglucinol, all these will show positive test for haloform reactions, right? This discussion already we have done in previous class. See this one, haloform reaction. Haloform reaction is positive. Compounds with alpha CH3 group 2 C double bond O shows positive test. Among primary alcohols, only ethyl alcohol. Among secondary alcohols, all 2 walls. Tertiary alcohols fail. Among aldehydes, only acetaldehyde. Among ketones, 2 ones. Chloral, resorcinol, fluoroglucinol, and active methylene group possessing compounds. All these will show positive test for haloform reaction. Over. Done. So we are done with preparation of iodoform, right? So I am writing one more preparation. Sir. CH3, CH2OH. Now tell me, do it show positive test, iodoform test or not? Ethyl alcohol shows positive iodoform test or not? So plus 6NaOH plus 4I2 in presence on heating gives rise to CHI3 plus HCOO minus Na plus 5H2O plus 5NaI. Iodoform test. So preparation of iodoform test is one. Clear? Next, regarding properties. Properties. Melting point 382 Kelvin. It has characteristics pungent smell, unpleasant pungent smell, insoluble in water, but readily soluble in organic solvents. Stop talking. Next, sir. Iodoform with hydrogen iodide, red phosphorus. What is HA and red phosphorus, sir? Strong reducing agent. If I provide excess amount of it, it will convert into methane. If I add only one equivalent, CH2I2. If it is allowed to react it further, right? CH3I, further CH4, right? Response, sir? No. If this is allowed to react with silver on heating, already we have seen. Silver on heating, what happens? 6 AgI is gone. So what do you get? Acetylene. Stop talking. No. If it is allowed to react with primary amine in presence of base, then what is the name of this reaction? Primary amines in presence of chloroform and base, carbylamine test. So what you will get? Isocyanide, pungent, rotten fish smell, right? So product will be CH3ENC. CH3ENC. Next, if it is allowed to react with AgNO3 on heating, silver nitrate on heating, what silver will do? Will go and take iodine. AgI is gone. If I add excess amount of AgNO3, 6 moles of AgI is gone. So product will be, if 6 moles of AgI is gone, product will be Again acetylene, C2H2, acetylene. Right, sir? Next. Iodoform, used as antiseptic for wounds. Used in manufacture of pharmaceuticals. So iodoform is over. Next, CCl4, carbon tetrachloride. Carbon tetrachloride, CCl4. First regarding preparation. Already you know this reaction. Methane with excess of chlorine in presence of sunlight. A radical mechanism. Explosive reaction, correct? So product will be CCl4. If methane is excess, CH3Cl will be major. Next, second reaction. Carbon disulfide, CS2, carbon disulfide with chlorine in presence of AlCl3. Then you will get carbon tetrachloride plus S2Cl2. Next, properties. It is a colorless, stop talking, oily liquid. Characteristic smell. Used as organic solvent. It is heavier than water. Insoluble in water, but soluble in organic solvents such as ether. Next, chemical properties. CCl4 on reduction, partial reduction in presence of iron. I'm adding two hydrogens. One H is added here, another H will take chlorine. So product will be CHCl3, correct, or plus HCl, chloroform. Next. CCl4 on strong heating forms COCl2, phosgene. stable, but vapors come in contact with water at high temperatures. Next, uses. Used as laboratory reagent, industrial solvent, used in dry cleaning. Nowadays, solid carbon dioxide is used as solvent in dry cleaning, right? Previous JE mains question, sir. Just a moment, I will show that statement and yes, sir, go. This dry cleaning of clothes. Tetrachloroethene, CCl2, CCl2, tetrachloroethene. Tetrafluoroethene is called Teflon. This is tetrachloroethene, was earlier used as a solvent for dry cleaning. The compound contaminates the groundwater and also a suspected carcinogen. The process using this compound is now being replaced by a process where liquefied carbon dioxide with a suitable detergent is used. Replacement of halogenated solvents by liquid carbon dioxide will result in less harm to groundwater. These days, hydrogen peroxide is used for the purpose of bleaching clothes in the process of laundry, which gives better results and makes use of lesser amount of water. Right? So here also we are seeing a dry cleaning. So C2Cl4. Tetrachloroethene is also used as solvent for dry cleaning. Now it is replaced by liquefied carbon dioxide. For bleaching, we are using hydrogen peroxide. Earlier, bleaching is done by chlorine. Now bleaching is done by hydrogen peroxide. Right? As a fire extinguisher, as this is used as fire extinguisher under the name pyrene. Pyrene is the name of the company. CCl4 is also called as pyrene. But organic compound pyrene is there, 4 benzene rings. Right? So pyrene is the commercial name of CCl4. So we are done with carbon tetrachloride. Next is heading, sir. Freons. Freons. Freons are nothing but chlorofluorocarbons. Stop talking. We call them as freons. Or we also write as CFCs. Example, CFCl3. It is also called as freon. What we can write? 0, 1, 1. Hydrogen is not there, so 1. Fluorine 1 is there. So 0, 1, 1. If it is CF2, Cl2, then 0, 1, 2. So freon 1, 2. These two are used as refrigerants. Right? Then CF3Cl. CF3Cl. Now 0, 1, 3. So freon 1, 3. CF3Cl bond CF3Cl. Now it is written as freon carbons 2. Right? 1, 1, 116. 116 6 fluorines. Right? It is a dimer, no? Right? Means it is CF3Cl dimer. So 0, 1, 3. Right? But it was mentioned as see this one. Freon 114. One comma 2 dichloro tetrafluoroethane. Who came and who went, man? Right. So what is it? 1 comma 2 dichloro tetrafluoroethane. So can I write as 1 chlorine on this carbon and 2 fluorines. So CF2Cl bond CF2Cl. Oh, I wrote as CF3. Yeah? CF2Cl bond CF2Cl. A carbon valency, man. Right? Now what I can write? 0, 1, 0, 1, 1, 1, 4. Correct now? Freons are extremely stable. Freons are extremely stable. Non-toxic, non-flammable, non-corrosive, colorless, odorless, highly unreactive, low boiling, easily liquefiable compounds. That's why they are used as refrigerants. Freon 112, its boiling point is minus 25 degrees centigrade. Freon 11. Freon 12 boiling point minus 30 degrees centigrade. I think it is waste to discuss in your class also. When you don't have interest, why I have to spend time? Next 2 chapters, sir, I will complete in 1 week. Saturday, Sunday, I will close the chapters. Why to write the notes also? Next, prions deplete ozone layer. Carbon tetrachloride, CCl4, in presence of antimony fluoride at 140 degrees centigrade forms prions. Close the door, man. Next compound, sir. Perfluorocarbons. Perfluorocarbons. If all the hydrogens of carbons are replaced by fluorines, we call it as perfluorocarbons. Example: C7H16, 16 moles of F2 in presence of vapor phase of nitrogen at around 300 degrees centigrade, cobalt fluoride as catalyst. Then all hydrogens are replaced by fluorines. So we can write a C7F16. So this is called perfluoroheptane. Similarly, Teflon. What is Teflon? Tetrafluoro CF2 double bond CF2. Teflon. Tetrafluoroethene. Polymer of tetrafluoroethene is called Teflon. Polymer of tetrafluoro, this is monomer. If it polymerizes, right, then it we call it as a tetrafluoroethane, Teflon. Non-stick coatings. Non-stick pans, right? That black color is nothing but Teflon. They are non-toxic, extremely stable compounds, non-corrosive, can be used as lubricant, as electrical insulator. Next one, PHC. We also called as lindane, benzene hexachloride. PHC, or we can also write as 666, or we also called as lindane. Of course, lindane is a isomer of it. This is lindane, right? Isomer of it. In order to kill that mice, huh? What we call it as lice, huh? Lice, not mice, huh? Okay. So this is lindane. So when benzene is allowed to react with chlorine in presence of sunlight, if there is no catalyst, if I don't use iron or FeCl3 or AlCl3, it will not show electrophilic substitution. It will keep on adding to pi bonds. If all the pi bonds are gone, what you will get? All pi bonds are replaced by chlorines. So we can write it as C6, H6, Cl6. That's why it is called 666, right? Benzene hexachloride. If the same benzene is allowed to react with chlorine in presence of either iron or FeCl3 or AlCl3, then electrophilic aromatic substitution. All hydrogens, if I use excess, all hydrogens are replaced by chlorines. Observe the difference. Hydrogens are replaced by chlorines. So this is electrophilic aromatic substitution, right? Electrophilic aromatic substitution reaction, right? So it is called hexachlorobenzene. Observe, this is called benzene hexachloride. This is called hexachlorobenzene. Don't get confused. Right. So for this compound, 9 stereoisomers are possible. In which 7 are meso and 2 are enantiomers. Its gamma isomer is called gamexane. It is insecticide. That ends polyhalogen derivatives also, which are present in Victor's book, right? So we are done with total alkyl and aryl halides chapter. Right, sir, we will solve some numericals. See this one? Go to page number 151. Exercise 9.5, question number 37. Exercise 9.5, question number 37. What they give? Chloroform with silver powder. What you will get? Just now we have seen. Chloroform, CHCl3, heated in presence of silver. What you will get? Acetylene. Acetylene passed over red hot iron. Benzene.
Sir, benzene.
Now, benzene with the dash forms chlorobenzene. Electrophilic substitution means chlorine in presence of FeCl3 or AlCl3, some catalyst must be there. Right? So answer must be. No? Which one? Third option. Next one. Dibromopropane allowed to react with zinc. What happens? ZnBr2 is lost. Response, sir. If ZnBr2 is lost, you will get alkene. Then you are doing monobromination. Maybe N-bromosexamide I am using, NBS. NBS will do monobromination only, na? I am using N-bromosexamide. Then what happen? NBS. It will do allylic halogenation. Correct? So I got double bond here. Here I've got Br. Monobromination I have done. Now what I am using HBr in terms of peroxide. Kanash effect or peroxide effect. Then Br goes to less substituted carbon. Correct or not? So I will get Br here. Double bond will be gone. And I will get, this is Br. 1, 2, 3. Here I will get Br. Now you are heating with zinc. ZnBr2 is gone. You will get cyclopropane. Correct? So which is correct one? So X is this. So yes, third option is correct. Online, respond. Yes or no?
Yes.
Next one, sir. This is iodobenzene. Iodobenzene need to convert into diphenyl methane. This in between, not biphenyl, man. Both benzene rings are not directly connected. They are connected to carbon, right? So biphenyl methane, right? Then how we have to do it? I am using hydrogen iodide on heating. If I use HI on heating, what happen? Benzene. HI, if I heat it with HI, what happen? I2 is eliminated, you will get benzene. That's why I have to use oxidizing agent, right? So that reaction will not go back. So definitely not option 1. Now I am using magnesium in terms of triether. If I use magnesium in terms of triether, what happen? It will convert into. Yes, sir. Okay, man, let it be. Let me solve. So in terms of magnesium triether, I will get this one. Then it is allowed to react with this. Then it is good source of R minus. Now this R minus will go and attack over this, making this Br to leave. So product will be first option. Means possible or not? Means product will be this. So here it is possible. Next. Benzyl iodide. So this is allowed to react with CH2I in presence of sodium. What is it? Fittig reaction. Sorry, Wurtz-Fittig reaction. Then from here I2 is lost. Then I will get it. So this is nothing but Wurtz-Fittig. So possible. So this is also possible. Next one. Magnesium triether. In presence of magnesium triether, what you will get? Magnesium triether. Grignard reagent. So you will get benzene, MgI. Now this is allowed to react with benzyl alcohol. We have acidic hydrogen. When you have acidic hydrogen, what happens? When you have acidic hydrogen, Grignard reagents are unstable in presence of acidic hydrogen. So this phenyl will go and take this H plus. If phenyl goes and take that H plus, what you will get? You will get benzene ring, correct? Plus remaining thing, PH, CH2, O, MgI. So what you got? You got benzene as a product. Means this is not at all suitable. This is not at all suitable. Oh, observe this. Observe this, sir. First case, when I heat with HI, when this is heated with HI, what happens first? You will get benzene. Benzene is allowed to react with CH2Cl2 in presence of AlCl3. What happens? First AlCl3 will take Cl minus from here. Then you will get CH2Cl plus. That will go and attack over benzene ring. So what you will get? On benzene ring, you will get CH2Cl, Friedel-Crafts alkylation. Now this can react with iodobenzene again. This and this reactant can react now. Then what I will get? Then I can get given product or not? Respond. So what should be the answer? Only fourth option is incorrect. Response, sir. Not only HA on heating, followed by CH2Cl2 in presence of AlCl3, Friedel-Crafts reaction. So on Friedel-Crafts reaction, I will get this product that can react with initial reactant to give this product. Clear? Response, sir. Any questions in it? Array, I am getting this one, man. This can again in with AlCl3, it can form carbocation or not? Again, it will show substitution or not? Again, this iodine will be replaced or not? Over. Right? Yes, sir. Yes, yes. Reduce, so you switch it off. Next question, sir. Select the option with correct set of reagents used in the sequence of for conversion of 3-bromopropene into butane. So we need to convert 3-bromopropene into butane. I need to do this, right? To do that, which is suitable? First, what you are doing? Hydrogen presence of nickel. What hydrogen presence of nickel do? Hydrogen presence of nickel reduction. So double bond will be gone. Then this also alkyl halides also react with the hydrogen presence of nickel to form alkanes. So final product will be propane. Then monobromination. If I do monobromination, you will get secondary bromo product because their radical is stable. Then NaNH2 elimination. So if elimination happens, again you will get alkene. Then reductive ozonolysis. What happens in case of reductive ozonolysis? Ozone in presence of CH2Cl2, zinc and H2O. What happens? This double bond will break, converts into aldehyde here, and this will also convert into aldehyde. Correct, sir? But you are not getting butane. So option 1 is gone. Now second option, what you are doing? Second option, again hydrogen nickel, same. Monobromination, same. After that, what you are doing? Heating in presence of zinc. If I heat that in presence of zinc, I have to remove ZnBr2. How can I remove ZnBr2? I will take 2 moles of it. If I remove ZnBr2, then what should be the product? Coupling reaction. Then what you are doing? I cannot do reductive ozonolysis. How can I do reductive ozonolysis? It is already alkane. So again, this fails. Next one. Next one, what you are doing? Monobromination. Already it is monobromo, right? Again, you are doing monobromination now. Already it is monobromo only, man. How you will do monobromination again? Then it becomes dibromo product. Means I am ruling out option 3 also. Now I am going for option 4. So definitely option 4 should be correct. Let me check. You are adding magnesium in presence of dry ether. Magnesium in presence of dry ether. What you will get? Coupling, na? Sorry, Grignard reagent you will get. So Grignard reagent means I will get double bond. Here I will get MgBr. Then what you are doing? Magnesium dry ether. Now you are adding 3-bromopropene. So this is allowed to react with 1, 2, 3. Now again 3-bromopropene. Right? Now this group acts as nucleophile. Correct? Or it is good source of R minus, na? R minus. Next one. So this is good source of R minus. Now this R minus will go and attack, make this Br2 leave. This R minus will go and attack here, making this Br2 leave. So what will be the product now? This one. On that again, 1, 2, 3. Again on that, 1, 2, 3. I should get this as the product. Correct? Here 1, 2, 3 carbons. Here also 1, 2, 3 carbons. Totally 6 carbons. 1, 2, 3, 4, 5, 6. 6 carbon product I got. After that, what you are doing? Now we are doing reductive ozonolysis. If I do reductive ozonolysis, what happened? Here it will break. Here also it will break. So I will get 2 moles of formaldehyde plus 1, 2, 3, 4 butane 2-one. Correct? No, not 2-one. Butane 2-all. 1,4 diol. So 1. This one correct or not? I got aldehyde at first position, second, third, fourth position. At first position, fourth position, I got aldehyde. Now what I am doing? Zinc amalgam in presence of HCl. What is it called? Clemmensen reduction. It is called Clemmensen reduction. So in Clemmensen reduction, what happened? Aldehydes will be converted to alkanes. So 2 aldehydes will be reduced to form alkane. So what you got? Butane. Done now? Respond. Any questions in it? So answer must be option 4. Nice question this is. Next one, sir. Select the option with correct set of reagents used in the sequence of conversion of chloroethane to butadiene. Chloroethane should convert into 1, 2, 3, 4 butadiene. This should be obtained. I need to convert chloroethane to butadiene. First I am adding H plus in presence of zinc. What it is? Zinc in presence of acids or bases, reducing agent. Right? Then it will convert it to alkane. If I use this one, I am talking about first option, sir. I am talking about first option. First, it will convert into alkane. Then you are doing monohalogenation. Means again you are forming this only. And first you got ethane, then again monohalogenation. Then sodium. If I use sodium in presence of dry ether, Wurtz reaction. If it is Wurtz reaction, what you will get? Butane. Response, sir. Correct or not? Then dihalogenation or dehalogenation? I think it is a dehalogenation. Dehalogenation. Okay, dihalogenation. So 2 times. Okay. Dihalogenation means I got 1 chlorine here, 1 chlorine here. Then NaNH2 in excess quantity. Alkyne. So 1, 2, 3, 4. So 1, 2, 3, 4 triple bond here. But what I should get? Double bond only, not triple bond. Means option 1 gone. So in option 1, product will be. In option 1, product will be but2-ine. Now come to option 2. OH minus aqueous converts into alcohol or aqueous base. So it will convert it to alcohol. Now we are using KMnO4, good oxidizing agent. So this will convert into carboxylic acid. It will convert into carboxylic acid because KMnO4 is a strong oxidizing agent. Alcohols will be converted to acids. If it's mild oxidizing agent, primary alcohols will stop at aldehydes. Best example, haloform reaction. Ethyl alcohol will convert into aldehyde. Next, what you are doing? Heating with soda lime. NaOH in presence of CaO. What happened? Decarboxylation means CO2 is gone. If CO2 is gone, what you will get? Ethane. Ethane. Then after soda alone, monohalogenation. Monohalogenation means again it will convert into chloroethane only. Then alcoholic KOH. And alcoholic KOH means elimination, na? So what you got? Ethene. So here I got CH2 double bond CH2 as a product. So that also failed. Next, third step, third reaction. What they are saying? Third reaction. Alcoholic KOH. So first it will convert into alkene. Then you are adding HBr. H plus and Br minus. Marconi cup product. So H plus and Br minus means it converts into CH3, CH2 Br. Now instead of chlorine, I got Br. Then sodium, which reaction? Sodium in presence of dry ether. What happened? Which reaction? Huh? What do you get? CH3, CH2, again CH2, CH3, butane. Then what you are doing? Monohalogenation. Monohalogenation means I will get 1, 2, 3, 4. I can get chlorine here. Secondary. Then alcoholic KOH. Alcoholic KOH means alkene. Sage product is major. So option 3 is suitable. Now come to option 4. What they are saying? First, they are using sodium in presence of dry ether. If it is sodium in presence of dry ether, which reaction? Which reaction means product here itself butane. After that, what you are doing? Monohalogenation. Monohalogenation means okay. Then means butene. Then HBr. Huh? HBr means again bromine. Now again alcoholic KOH. Oh, I can do monohalogenation like this also. Allylic. This is also monohalogenation. No? It is also monohalogenation by using allylic. So first, what they are doing? We are adding HBr only. And in fourth option, we are adding HBr. HBr means obviously I should get. HBr means obviously I should get this product only. Then again alcoholic KOH means I will get this only as the product. No? Sageoff and Hoffman. Then why option 3 is wrong? Option 4 is correct. Option 3, let me check option 3 also one more time. What we are doing in option 3, first you are using alcoholic KOH. Alcoholic KOH means this will convert into alkene, correct? Huh? Respond. Then you are adding HBr. On adding HBr, what happened? CH3, CH2 Br. Then you are adding sodium in presence of dry ether, butane. After that, what you are doing? Monohalogenation. Monohalogenation means I will get bromine here. Then what you are doing? Alcoholic KOH. Alcoholic KOH means I will also get same. So both are suitable answers only then. They are asking good yield. Right? Good yield. See here. As carbon chain length increases, what happens to which reaction? Percentage yield decreases. Here, where you are doing which reaction? In the first step only. Correct? They are also same only. They are also same only. Both are suitable, man. Alcoholic KOH. Elimination. Then you are adding HBr and then you are adding Uj reaction. After that, you are doing monohalogenation. Oh, now I understood. After forming this, after forming butane, you are doing monohalogenation means I may get different possible products, right? Right. After forming butane, we are doing monohalogenation means I can form bromine either here or here. Two possibilities. If this is it, I got this one. If this is it, I will get this one. Correct or not? So what happens to percentage yield? Decreases, because monohalogenation I can get different possible products. Correct? Here such possibility is not there. Right? So both cases I will get same product, but with good yield I will get in option 4 only. Are you able to understand? Clear or not? Any questions in this? Next one. Select the option with correct set of reagents used in sequence of conversion of 3-chloropropene into benzene. We need to convert 3-chloropropene to benzene. Okay. Sodium diether. Answer is option 2. What we have done? First we have taken sodium in presence of diether. Right? Wait. They want benzene, na? They want benzene. What the heck? Answer is option 3. Observe here. First you are adding magnesium presence of diether. What you will get? Magnesium presence of diether? Grignard reagent. So Grignard reagent means I will get here MgCl. Then what you are doing? Then you are adding 3-chloropropene. So I am adding 1, 2, 3. 3-chloropropene. Then what happened to this one? This total group act as R minus. This R minus will go and attack over this, making this chlorine to leave. Then what is the chain length? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. I got one double bond here, one double bond here. Then after that, what I am doing? Hydrogen presence of nickel excess. So it will convert into N-hexane. After N-hexane, I am using Cr2O3 on heating. What we call as aromatization. So I will get benzene. Correct or not? Alkanes on heating presence of chromium oxide. You will get aromatization reaction. You will get benzene. Clear? Any questions in it? So answer is option 3. Next one, sir. All these are conversions only, sir. All these are good questions. At least if you listen here properly, you will get total chapter. Online, any questions, sir?
No, sir. No, sir.
Remaining all are sleeping only.
No, sir.
No, sir.
No, sir.
Right, sir.
No,
Now see this next question, sir. Select the option with correct set of reagents used in the sequence of conversion of 1,2-dibromopropane, 1,2-dibromopropane into propenyl magnesium bromide. Propenyl magnesium bromide. So I need to convert that into this, right? So what you are doing first, NaNH2 excess means 2 times I have to remove HBr. Means it will convert into alkyne. Then reduction means it will convert into alkane. Then bromine presence of CCl4. Nothing happens. First reaction failed. Hydrogen presence of nickel. Alkane. Answer is option 4. Now see this. First I am adding zinc, sir. On adding zinc, what happened? ZnBr2 is gone. If ZnBr2 is gone, you will get alkene or not. Then we are adding NBS, N-bromosuccinamide. What they will do? Allylic or benzylic halogenation means you will get bromine here. Then you are adding magnesium presence of diether. If I add magnesium presence of diether, now you will get this one. Correct or not? So answer is option 4. Any questions, sir? Question number 44. Next one. Select the option with correct set of reagents using the sequence of conversion of hexane. 1, 2, 3, 4, 5, 6. Hexane should convert into biphenyl. Should convert into this. Oh, okay. Answer is option 3. First, what we are doing? Cr2O3 at 773 Kelvin. What happened? Aromatization. Means first I will get benzene. Now benzene is allowed to react with bromine in presence of iron. Bromobenzene. When bromobenzene is heated in presence of sodium, dry either. Fitting reaction. Biphenyl. Correct? So answer is option 3. This is also okay. Next, sir. 46. Conversion of dibromomethane. So CH2Br2, dibromomethane, should convert into phenol. Dibromomethane. Methane only, na? Oh, dibromoethane. Dibromoethane means I can assume dibromoethane in this way. Either geminal or maybe piscinal. Right? Both are dibromoethanes only, right? Convert into phenol. So first I am using alcoholic KOH followed by NaNH2. Alcoholic KOH means one HBr is lost. Second HBr it cannot remove. So that's why NaNH2 removes second HBr also. So in this case as well as third case, fourth case, in these 3 cases, you will get alkene, right? So CH triple bond CH alkene. Then I am passing through red hot iron tube. Then what I will get? Benzene. Then chlorine in presence of FeCl3, chlorobenzene. Then heated in presence of NaOH at high temperature, Dow's process. So what you will get? Phenol. So answer is option 4. Response, sir. Any questions? Right. Now come to step 1. At least for this UT, you have 2 chapters only. One is coordination compound. Second one is haloalkanes, right? Halo and aryl halides, alkyl and aryl halides, right? So I am solving this. At least you at home you solve that, right? Few questions, right? And now say this one. General formula of alkyl halides. Alkyl halides, man. Are CH3X. So formula is CN H2N plus 1 X. Next one. Geminal dibromide. So geminal dibromide. So carbon bromines must be on same carbon. So answer is second option. Which of the following is an example of vicinal? Means adjacent. So 1,2-dichloroethane. What is the IUPAC name of this compound? This is C2H6. Means I need to start counting from here. 1, 2, 3, 4. Here 2 carbons are there. Na? CH3, CH, CH2, CH3. Correct or not? Bond CH2, Br. So I need to start numbering from here. 1, 2, 3, 4. 4 carbon chain. So 1 bromo, 2 methyl butane. 1 bromo, 2 methyl butane. Next. Haloforms are trihalo derivatives of methane. Response, sir. Next. Full name of DDT. IUPAC name they are asking or common name. Correct or not? Right? So can I call it as 1,1,1 trichloro bis? Correct or not? All right, from here I am starting numbering 1 and here I am giving number 2. Correct? So 1,1,1 trichloro 2 comma 2 bis 1, 2, 3, 4 4 chlorobenzene ethane. Correct? Answer is option 1. Correct or not? 1,1,1 trichloro 2 comma 2 bis parachlorophenyl. I am calling it as 4 chlorophenyl ethane. Next one. What is the type of isomerism exhibited by them? Positional isomers. Here both chlorines are on same carbon on adjacent carbons. This is 1,1 dichloroethane. This is 1 comma 2 dichloroethane. So they both are positional isomers. How many structural isomers are possible for C2H4Br2? 2 only. So CH3CH Br 1 possibility. Other possibility is CH2Br CH2Br. So that's all, no? Is there any other? So answer is 2. Next one. Order of reactivity of following alcohols with halogen acids are a groups process. We are talking about alcohols. Alcohols react with HX. If it is tertiary alcohol, it will react quickly because it will form stable carbocation. Primary, secondary will react slowly. That's why I require catalyst. Right? ZnCl2 is required. So tertiary more reactive than secondary than primary. So answer is CBA. Correct. Next one. Which of the following alcohols will yield corresponding alkyl chloride on reaction with concentrated HCl at room temperature? Right? Which one? Fourth option. It will give precipitate immediately. Response, sir. Tertiary alcohols, na reaction occurs very quickly. Immediate precipitate we will get via SN1 mechanism. Right? Secondary alcohols after 5 minutes. Primary alcohols after 20 minutes or on heating. This is also primary alcohol. So in these two is not there. So answer must be option 4. Next one. Toluene react with halogens in presence of FeCl3. So I'm writing chlorine in presence of FeCl3. What you will get? What type of group chlorine methyl group is? Ortho-para-directing, ring activating ortho-para-directing group. So I will get chlorine either at ortho position or maybe para position. Generally, which is major? Para will be major because less repulsive interaction. So this will be major. Right? Ortho and para, they already told. This reaction is called electrophilic substitution reaction. So answer is respond. Next one. Arrange the following compound in increasing order of their boiling point as chain length increases. Boiling point increases. All are isomers or not? 4 carbons, 4 carbons, 4 carbons. Right? So which is having highest? So B greater than, A greater than C. So B, A, C. Correct? Next. You are adding HCl. What happened? HCl will attack on double bond, not on benzene. Attacks on double bond. So what should be the product? First H plus will go and attack. Marconi का product na? Marconi का product. First H plus will go and attack. You will get CH2, CH, CH2, CH, positive charge CH3. This is secondary carbocation. Now carbocation undergo rearrangement, no? Because benzyl carbocation is more stable than secondary carbocation. Respond. So it will undergo rearrangement. Then Cl minus will attack. So product will be fourth option. Correct or not? So you got carbocation, rearranges to benzyl carbocation, then Cl minus will be added to that. Correct? Next, reaction of toluene with a limited amount of chlorine in presence of sunlight. What happened? Chlorine will go and attack on methyl group. If it is catalyst, then it will attack on benzene ring. If there is radical mechanism, it will go and attack on carbon chain. So answer must be first option. Next. What is this? C3H8. Huh? C3H8 means propane. Propane in presence of chlorine and sunlight. What should be the product? Correct? This one or maybe this one. Two possibilities. Which is major? Or they will react in the ratio 1:3.8:5. Correct? So how many primary carbons? 2. So 6 hydrogens. So 6:2. Secondary hydrogens are 2. So 2 into 3.8. 7.6. Correct? So major will be this one. So this is major. Next, what you are doing then? Gives a mixture of 1 chloro and 2 chloro on reaction with HCl. Chichi. No, above question. This is an example of which of the, what is it? Answer is substitution, radical substitution reaction. Radical substitution. Next one. Which of the following organic compounds will give 1 chlorobutane and 2 chlorobutane on reaction with HCl? 1 chloro and 2 chloro. They are saying butane, not butene. Answer must be fourth option. Respond. Correct? You are getting 2 chlorobutane means major, Marconi. Right? 1 chloro means anti-Marconi. Next one. Which of the following is an halogen exchange reaction? What is this name of this reaction? Sodium iodide in terms of acetone. Finkelstein. This is halogen exchange. You are adding HX means it is addition reaction. Correct? I am adding HX to double bond. So it is called electrophilic addition. Then alcohol with HX in presence of ZnCl2. What is it? Grooves are Lucas. Correct or not? OH is replaced by X. Right? So Lucas are grooves. Next one. Toluene reacts with halogen presence of iron. This is donating group. Ortho para directing. Correct? So among these two, which is better ortho para directing? Methyl. Its ortho position is this. Its para position is this. So answer must be, oh, they gave this same only. Oh, no. In first case, they have not given substitution. Huh? What they give? X and X2 only. How can I say it as halogen exchange? If they give iodine, if they give another halogen here, then I call it as halogen exchange. Correct or not? How can I call this as halogen exchange? Right? So answer is only first option. Next one. Ethyl alcohol on reaction with SOCl2. What is this reaction? Sargents. And proceed via SNI mechanism. Correct? So product will be. Correct, sir? First step it will form CH3, CH2, O, SOCl. In next step, correct, sir? Next one. Which of the following compound will give racemic mixture on nucleophilic substitution with OH minus? Means nucleophilic substitution giving racemic mixture means it should proceed via SN1 mechanism. Inversion slightly dominates retention. So SN1 mechanism. So it should be respond. Oh, they want order. They want order. Which of the following compounds will give racemic mixture? Okay, which we will give? They are talking about all. Now see this. Is it chiral carbon or not? You will get carbocation. Shh. You will get carbocation. If you are getting carbocation, it will be planar. OH minus can attack either above the plane or below the plane. So A is correct. Here also it forms tertiary carbocation. Again planar. So A correct, B correct, but C also correct only. Na? First this Br will be replaced to form carbocation. Then rearrangement. Correct? If this H comes here, then it is not chiral carbon. This side methyl, left side also methyl. First you will get CH3, CH, C2H5. I got CH2 plus here first. Then from here, hydrogen migrated. Then what you will get? CH3 bond, C bond, CH3 bond, C2H5 plus, correct? Even if you get OH here, it is not chiral, no? Both are methyl groups only. Same way here also it is not chiral. Both are methyls only. So answer is only A, because these two are not giving chiral product. So answer is only A. Respond. Next one. Which of the following carbon atoms present in the molecule given below are asymmetric? Right? Means they are talking about chiral carbons. Which are chiral carbons? So B and C are chiral carbons or not? 4 different substituents. A and D have unsaturation. Right? So answer is B and C. Next one. In which of the following molecules carbon atom marked with star is asymmetric? Means which is chiral carbon? A is correct. B is also chiral. C also chiral. C is not chiral because both hydrogens. So answer A, B, C. Primary amine with NaNO2 in presence of HCl or HNO2, benzene diazonium salt. That with Cu2Cl2, cuprous chloride. What is it called? Sandmeyer. Correct, sir? So you will get chlorobenzene. We call this reaction as Sandmeyer reaction. So answer must be option 1. Correct or not? Next one. A primary alkyl halide would prefer to undergo primary man. If it is secondary, if it is tertiary, SN1. Primary, SN2. Then racemization will not happen. Racemization means it should be chiral. Impossible. Alpha elimination. Alpha elimination means elimination should happen on the same carbon. Right? So primary alkyl halide would prefer to undergo SN2 is correct. Alpha elimination also can be correct. No. To undergo alpha elimination should be primary polyhalide. Or it should be CHCl3, not chloroform. Response, sir. To get halogens to be eliminated, it should be polyhalide, no, not one single halide, alkyl halide. It should be a polyhalide. So answer should be SN2. Next one. First is correct explanation, not correct explanation. A true or false, A false or true. Okay. Thionyl chloride means SOCl2 is preferred over phosphorus chlorides, PCl3 and PCl5 for preparation of alkyl halides from alcohols. Correct only. Phosphorus chlorides give better yields of product as compared to thionyl chloride. No. Why SOCl2 is preferred? SO2 gas is escaped. Equilibrium reaction shifts in forward direction. So assertion is true. Reason is false. So answer is 3. Correct? Boiling point of alkyl halides decreases in the order. Correct. Iodides heavier molecular weight. So assertion correct. Boiling point of alkyl chlorides, bromides and iodides are considerably higher than that of hydrocarbons of comparable molecular mass. Correct. But both are not reason to each other. Compared to normal alkanes, chlorides, bromides, iodides are having higher boiling point. They have dipole moment. Normal alkanes doesn't have dipole moment. Therefore, they have dipole interactions. Therefore, boiling point will be high. Correct or not? So, reason is correct, assertion is correct, but both are not explanations to each other. A correct explanation will be due to higher molecular weight, alkyl iodides are having more boiling point than bromides, than chlorides, than fluorides. Correct or not? Right? So answer must be option 2. KCN reacts with methyl chloride to form isocyanide. No. If it is AgCN, isocyanide. KCN, cyanide. CN minus is an ambidentate nucleophile. It is an ambidentate nucleophile. Both are correct statements, but not correct explanation to each other. What? Okay. Right. The assertion is wrong. Reason is correct. So answer is 4. Next. Aryl iodides can be prepared by reaction of arenes, means benzene, with iodine in presence of oxidizing agent. Correct. Oxidizing agents oxidize Hi to I2. They wrote I2 to Hi. Right? They will remove Hi to I2. That's why equilibrium shifts in forward direction. Right? So answer is assertion right, reason wrong. Means third option. It is difficult to replace chlorine by OH group in chlorobenzene in comparison to that of chloroethane. Correct. That's why Dow's process is difficult. Chlorine carbon bond has partial double bond character. Correct. Because chlorine will donate lone pair of electrons into that p orbital of carbon. So correct only. So due to resonance. So both are correct. So answer is 1. Next, draw the structure. All these are nonsense. Board, you prepare for it. Now coming to step 2, sir, I will stop solving numericals of alkyl and aryl halides here. Right? In next class, we will see again few questions. We will continue. Right? So next chapter, sir, alcohols, phenols, ethers. Again, I am saying, if you don't listen properly, in these 20 minutes, I will complete the chapter. If you listen properly, I will give the notes and I will explain. I am keeping that reference book also open so that I should not miss any point in it. Anyhow, you are not studying at home. At least here you study it. I am reading that book completely. Every point I am reading. And I am writing again. So that at least once you will read it. You keep on discussing means what is the use then? Why I have to write? Time waste only. Oh, one more paper is there, sir. Tomorrow, everyone is writing one Ante paper, na? Ace Ante. Do you know this? From coming year, we are not giving admissions to everyone. From coming year onwards, there is selection process. Till now, anyone can pay the fees and can join, na? Right? So it is like a time pass place. From coming year, through selection process only, we will give seat. There is no fee concession, whoever you are, whatever the marks you got, right? If you are selected, if you are interested, then only you will come. Otherwise, go to competitors only. Right? In that way, we are planning to take only 30 admissions. That's all. We don't want these many faculty, these many batches, these many classrooms, this much big building, nothing required. Right? So for that, we are conducting one exam called ACE Ante exam. Now I have doubt whether if I give 8th class paper for you, whether you can qualify in it or not. Class 8th paper only this is. Right? Okay. Sorry, 8th means long back. At least the 10th. Huh? Shall we solve class 10th? This is class 10th paper. All right? Solve. Question number 41. Size, huh? Solve 41. Same way for foundation also, we are going to take again 30 foundation students. Those who have completed 8th coming to 9th. There is no admissions into 10th. There is no admissions into 12th. Those who have completed 8th coming to 9th, again they have to write exam. Only 30 again. Only engineering faculty will take their classes. There is no separate foundation team, no foundation, nothing. Right? 8th to 9th, 30 students, 9th, 10th, 11th, 12th. 4 years we only teach. By the year of completion of 10th, we will complete total 11th portion. 2 years. Actually, we will complete 11th portion. When they come to 11th, we will complete 12th portion and we will do revision of 11th. When they come to 12th, revision of 12th, complete solve. Right? Then we will get ranks. Okay, this is the thought. So 30 admissions only into class 9th. Right? Those who are already present, the existing students we will not disturb. New admissions, no. Only into 9th admissions are there, that too for 30, not even a single rupee concession. If you want concession, go. We don't want, we want only 30 people. Right? We have 240 foundation students this year. Right? I tortured them, at least 40 to 50 students. I made them to run away. In the month of August also, 6-7 admissions happened. Now we need to teach everything. I told, thank you, get lost. In 12th also, I think 2 days back on new student from our neighboring building. I clearly told in the class itself why you came now. What is the use? If you are not able to do anything there, what you can do here? Nothing. So changing building, shifting buildings will not have any use. Right? If you are seriously studying, whether you are studying here or at home or even at school is sufficient. No need of anything. Don't think that way. Same way, 10th also. For 10th completed students, they have to go through this paper. This is sample paper. Tomorrow they have another paper. This is sample paper. For them also, we are going to handpick. After completion, there will be one interview round. If they are selected in that interview round, then only admission. Right? We also started rejection process. Fees is premium. Maximum fees we will pay. 30. Right? Why to teach so many classes? With the 70,000, 80,000 fee structure. Even if you have 200 students, 4 lakh fee structure, 30 students. 1.2 CR. 200 students with 60,000 fees average. 1.2 CR. Why do they have 200 students? Take 30 only with maximum. Seat guarantee. That is better, na? Energy, so much energy we can save. Same way, medical also we are planning. MedPro, NEET Pro. MedPro, admission from 8th to 9th, 30. Again, 10th to 11th, 30. NEET Pro means RM student. RM students, those who are above 400 marks in NEET are based upon coming NEET. This year, I think above 400 we are taking. We have this year, now we have taken only 3 batches. 4th batch also after final they came, right? So next year we are planning only for 3 batches of RM. Last year we have 16 batches, right? So if we have more crowd, negative will be more. Take less crowd, quality crowd. Remaining will due to competitors, obviously our fame will increase. We will recommend you go there. You be there. Obviously our quality, our value rises. Correct now? That is the strategy we have. Hardly 7 batches. 7 faculty. Enough. Right. Start. As temperature increases, average kinetic energy of molecules increases. Correct or not? K equal to. What is formula? K equal to 3/2 RT. Correct or? Average kinetic energy equal to 3/2 RT. What would be the effect of increasing temperature on pressure, provided the volume is constant? If volume is constant, what is the effect of increasing temperature on pressure? They are saying average kinetic energy is constant. Average kinetic energy is constant means what is the meaning of it? Force exerted on the walls of container increases with increase in temperature. Means what happens to pressure? They kept the volume constant. At constant volume, if I increase temperature, what happens to pressure? Increases. On increasing temperature, kinetic energy increases. Means force exerted increases. Means pressure increases. No need of first statement also. At constant volume, pressure is directly proportional to T. For every 1 degree centigrade rise in temperature, pressure changes by 273rd part of original pressure. What is it? Gay-Lussac's law. Right? So answer is based upon the statement given here, choose the correct statement. Gases can be cooled and converted into liquid below its critical temperature. Correct. Array, what is critical temperature? The temperature above which, whatever the pressure you apply, they cannot be converted into liquid. Right? So below critical temperature, yes, we can convert. So P is correct. Above critical temperature, a gas cannot be liquefied, however greater the pressure. Correct. So answer is both P and Q explains P. Next one. Which of the following sets of phenomena increases with increase in temperature? If I increase temperature, diffusion, random movement of gas molecules increases. Evaporation increases. Liquefaction decreases. So answer A is wrong. B is wrong. Evaporation, C is correct. Number of electrons in an atom with atomic number 105 having n plus L value 8, 105, 14, 3, 17. Answer is 17. Array 105, 1s2, 2s2, 2p6, correct? Huh? Right? Again, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, then 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d3 over 10, 20, 30, 38, 48, 48 plus 8, 56 plus 14 plus 10, 88, 88 plus 14, 102 plus 3 over 105, right? Now what they are asking in it? N plus L value should be 8. What is N plus L value of 5F? N is 5, na? L equal to 0, 1, 2, 3. Correct? F orbital. So F orbital L value 3. N plus L value 8. So 5F. What about 6D? 6D 8. 7S 7 only. 6P 7. 5D 7. 4F 7 means remaining all are less than 7. So 8 means only over 17. Correct? Right. Next. What I have done. What is it? Radon. Right? After radon, up to 103. Up to 103. Actinoid. 104, 105. Correct or not? D1, F14, D2, D3. So F14, D3. Next. Which of the following would have highest weight? And 2 moles of CaCO3 weight is 200. 10 moles of H2O, 180. 2 moles of carbon dioxide, 88. 0.2 moles of sucrose, 342 into 0.2. 34.2 into 2. 68.4. Correct? Next one. According to Bohr's model is valid for hydrogen atom or ions containing 1 electron systems. Correct? More than one answer type. Next. An electron revolves in a fixed orbit and does not loses energy during revolution. Correct only. Bohr's postulate, man. As long as an electron is in a particular orbit, its energy remains constant. That's why they are called as stationary states. Correct? So correct statement only, na? Angular momentum of an electron is quantized. Yes, MBR equal to NH by 2 pi. When an electron jumps from higher orbit to lower orbit, energy equal to energy of higher orbit is emitted in the form of photons. No, difference in energy is emitted as photons, not energy. Correct? Means this is wrong. So answer is ABC. Choose the correct statements. Uranium 92-235, 92-237 are isotopes. Same atomic number, different mass number. Correct? Isotopes only. Yes, correct or not? Next, isotones. Difference should be same. 20-20. Number of neutrons are same. Ammonia, methane are isoelectronic. Yes, 7 plus 3, 10. 6 plus 4, 10. Isobars have similar chemical properties. Isobars have same atomic number, different in mass number. Atomic number is same means electrons also same. Means chemical properties are same. Chemical properties are because of electrons only, na? Physical properties because of weight. Mass number is changing means their weight changes. So physical properties will change. Correct? Correct only, na? Isobars means same atomic number. Sorry, same mass number, different atomic number. So chemical properties are different. Means wrong. Correct, correct. Not isotones, right? So isobars, na? So D is wrong. Right or not? Next. For the first order reaction, chemical kinetics, man. First order reactions, degree of dissociation is equal to 1 minus e power minus kt. Correct? Right. Degree of dissociation. See here. I am taking A gives rise to products. At time t equal to 0, initial concentration I am writing it as A naught. After time t equal to t, let the concentration be AT. According to first order kinetics, what is AT? AT equal to A naught into e power minus kt, correct? Instead of writing AT, can write A minus A alpha. And if initial concentration is C, C minus C alpha. Similarly, I will write AT as A naught minus A naught alpha. Correct? Huh? Respond. Instead of 80, can I substitute that? So A naught into e power minus kt equal to, I am taking A naught common, A naught into 1 minus alpha. A naught common, cancel. So what is alpha equal to? 1 minus e power kt. So correct only. Respond. Next, what they are saying. Plot of reciprocal concentration of reactant versus time is a straight line. Plot of reciprocal concentration, one upon concentration versus time gives a straight line. No. First order, no? First order means what is formula? K equal to 1 by T. Okay. 2.303 by T log A naught upon AT. Bring this to this side. Minus KT upon 2.303 is equal to log AT minus log A naught. If I plot a graph between log A naught versus T, then intercept is this, slope is this. So slope is negative, intercept is this. So the intercept is, this is AT, log A naught and slope equal to KT upon 2.303. Correct? Respond. Correct or not? Then only you will get a straight line. But what they are saying, if I want to plot a graph between AT versus T, see this. AT is equal to A naught into e power minus KT. This is the formula. Now, 1 upon AT is equal to 1 upon A naught into e power KT. Correct? Say something. So I am plotting a graph between 1 upon AT versus T. How the graph is? If a T increases, this total value increases exponentially. Respond, sir. So the graph must be exponential increase. Are you getting a straight line or exponential curve? Correct? So that is wrong. Say something. Next one, sir. Time taken for 75% completion is thrice the T half. No, twice the T half. Array, one T half means half. Second T half means 25% gone. Means 75% gone. So it is only 2 times. Means this is also wrong. Pre-exponential factor in Arrhenius equation has a dimensions of time inverse. Pre-exponential, we know K equal to A e power minus EA upon RT. What is this one? This is fraction, no? Right? So remove that fraction. Then what are the units of A? A units is nothing but K units. For first order, K units is per time. So A units is per time. Respond. Right? So answer is D correct. Next question, sir. Graham's law of diffusion. Some nonsense is there. Time up, huh? Okay, go. Hardly 2 more questions. For Graham's law of diffusion, okay, we will see later. I will stop the discussion. All right, sir. Array, at least, even if you start preparing properly from now, you can get very good marks in mains exams. Right? I'm saying very seriously. If you don't realize, again, same trouble. Right? Carry on. Go home. Bye, sir. I will end the session. Online students, I'm closing the session. Thank you.
Thank you, sir.
Right, sir.
Thank you, sir.
Notes I will post.